In this lesson, we'll talk about Pythagorean theorem and distance formula. Why is it important for us to know how to simplify roots? Well, in many geometry problems, we are seeking the exact solutions. For example, we may be asked to find the exact length of a third side in a right-angled triangle, or the exact distance between two given points. Anytime we're asked to find exact solutions, we will be most likely dealing with radicals, which means we need to be able to simplify them. Let's recall Pythagorean theorem. This theorem refers to a right-angled triangle. If we name the shorter sides, called legs, by A and B, and the hypotenuse, the longest side, by C, then the sum of squares of A and B is equal to the square of the C. So Pythagorean theorem states that a triangle is a right-angled triangle if and only if the sum of squares of the legs, the shorter sides, is equal to the square of the hypotenuse, the longest side. Geometrically, it states that if we build squares on each side of the right-angled triangle, somehow like this, and here's the largest square built on hypotenuse, then the total area of those two small squares, if we add these two areas, it will be equal to the area of the largest square. Notice that the area of a square with side A is called A square. The area of the square with side B is B square. And the largest square has area C square. That's why A square plus B square equals C square. Also notice that this theorem goes both ways. It's not only that we know that for a right-angled triangle the relation between its sides is A square plus B square equals C square, but the other way around. If this relation between any three quantities holds, then a triangle with sides A, B, and C is actually a right-angled triangle. So, for example, to prove that a triangle is right-angled, it's enough to show that the three lengths of its sides satisfy the Pythagorean equation. So let's apply Pythagorean theorem to find the unknown side given the following information. In example A, we have given A and C. We may want to quickly sketch the triangle and place this information on the diagram. So if this is right angle, that's a hypotenuse, so it is 12. And A is 4. Let's say A is this side. We are looking for B. According to the Pythagorean equation, we know that 4 square plus B square is equal to 12 square. When setting up this equation, always keep in mind that the hypotenuse, which is the longest side, must stay by itself on one side of the equation. Okay, so let's solve it for B. We'll keep B on the left-hand side, and then 12 square is 144. However, this 4 square, when we move to the right-hand side, it becomes negative 16. And this is 128. Finally, since we want B by itself, we need to apply square root to both sides of the equation, which gives us B equals square root of 128. Let's factor 128 into a perfect square number, 64, and something else, times 2. Now, since root of 64 is 8, and the 2 has to stay under the root, we end up with 8 root 2. So that's the exact length of side B. Okay, let's look at example B. A and B are given. So A square, meaning 3 root 2 square, plus B square, which is 5 root 2, and we square it, equals C square. We are after C. Okay, let's perform the squaring. Square of 3 is 9, square of root 2 is just 2, and here we have 25 times 2. Okay, that's C square, and I want to start with C square first, equals 25 times 2 is 50, and here we have 18, so 50 and 18 is 68. Therefore, our C by itself is square root of 68. How can we simplify this root? Well, let's factor 68. 68 is 2 times 34, but 34 is 2 times 17. Okay, so we can pull 1, 2 out and give the final exact answer for C as 2 root 17. Here we go. Notice that in both cases, here when we took square root of b squared, and over there when we formally took square root of c squared, we should end up with two possible answers, positive or negative. However, when we play with distances, we always expect to have a positive answer. We neglect the negative possibility. Why? Just because distances are always non-negative, right? So that's the only reason I didn't really consider the two possible signs. Let's see the next example. Well, this time the c value is not a specific number, it's just an expression. Let's draw a diagram to picture out the situation. Here's our right angle triangle. The a side is given as 1, the b we don't know, right? And c is given as an expression, root of n plus 1. So we can figure out the length of b in terms of n. Again, using Pythagorean equation, we start with adding the squares of shorter sides. So it's 1 square, which is 1, plus b square, which we don't know, equals c square, which is root of n plus 1 bracket square. But as we know, the square cancels the root. So on the right hand side, we really have just n plus 1. On the left-hand side, we have b squared plus 1. So let's move this 1 to the right. That becomes negative 1. And then we can reduce the positive and negative 1, leaving us with b squared equals n. However, after taking square root on both sides of the equation, b by itself becomes just root of n. So this time, the length of b is given as an expression. But that's okay. Now, how do we find the distance between two given points? Let's say our points have coordinates x1, y1 and x2, y2, as on the diagram. To find the distance between them, we apply Pythagorean equation to the right angle triangle obtained by projecting those 2 points vertically and horizontally in such a way that these two projections meet at the right angle at the point with coordinates x2. You see these 2 points have the same first coordinate, x2, that's this point, right? And y1, here's the y1. Okay, so this intersecting point has coordinates x2, y1. Okay, when we apply Pythagorean theorem to this right angle triangle, the hypotenuse square, which is d square, is equal to a square. And how long is that distance? Well, that's the difference in first coordinates of these 2 points, right? So it is x2 minus x1. Here's x2, here's x1, right? This distance is our a. So x2 minus x1, that's our a, and we are squaring it, plus, and we're taking b squared. But what's b? The b is the distance between y coordinates of these 2 points. So it is y2 minus y1. y2 minus y1 from here to there, right? Okay, so we can write the formula like this. And to find distance by itself, we apply square root to both sides. Therefore, we obtain the distance formula as you see here. Square root of sum of squares of differences between the x coordinates and y coordinates. Let's use this formula to find the distance between each pair of points. In the first example, we have given 2 ordered pairs of points. This is really our x1 and y1, and that's x2 and y2. Let's follow the formula and calculate our distance. The distance is square root of, we're taking the difference between the first coordinates. So it's 2 minus negative 5. watch the double negative here, and square it. Then plus the difference between y coordinates, so -3 minus 7, and square it. And the rest is just using arithmetic and order of operations, right? So 2 minus -5 is like 2 plus 5, so it's really 7 square. Plus, if we have -3 and -7, it's like -10. But since we are squaring it, the negative doesn't matter, because when we square a negative, it becomes positive. So instead of writing -10, we can write 10 as well. 10 square. Okay, finally, 10 squared is 100, 7 squared is 49, so our exact answer is root of 149. And that's all what we can do here, because 149 doesn't look like it's divisible by anything useful. This seems to be a prime number. It's not divisible by 2, 3, 5, neither 7, nor 11, nor 13. So that's definitely a prime number. We'll leave the answer as it is. That's the exact form. And let's try the second pair of points. This time the coordinates are a little bit more demanding because of those roots. Okay, the distance is square root of, and we are going to make the difference between x coordinates. It actually doesn't matter which point we'll start with. So we can start with 2 root 2 and subtract this root 2. 2 root 2 minus root 2, and then square it. Plus, again, difference between y coordinates. So we can say root 3 minus negative root 3. Root 3 minus negative root 3. And then square this difference. Let's see how much we have. 2 root 2 minus 1 root 2 is just root 2. Okay, so we have root 2 square. The square will cancel the root in the next step. And here we have root 3 plus root 3, so it's actually 2 root 3. And then we square it. Equals root 2 square is just 2, and when we square this expression, 2 square is 4, and root 3 square is just 3. So altogether we have 12 plus 2 is 14, root 14. Again, there's nothing more to simplify, so that's the final answer. Let's practice. Find the perimeter of the triangle. Here we have a triangle with given coordinates of the vertices. For easy reference, let's name those vertices by A, B, and C. So to find the perimeter, let's call it P, we need to add the three distances, AB plus BC and plus AC. Just by looking at the diagram, it seems like AB is equal to AC. But because we want to practice using the distance formula, let's calculate all those distances. Maybe underneath. Let's calculate distance AB first. Okay, so this point minus that point by coordinates. So square root of 6 minus -3, square it, and then plus 2 minus -3, and square it. Let's calculate how much is that. Here we have 6 plus 3, so it's 9. 9 square is 81. And over there we have 2 plus 3, it's 5 square, so it's 25. Altogether we have a root of 106. 106 can be factored into 2 times 53, but then 53 is a prime number, so we won't be able to take anything out of this radical anyway, so we can leave the answer as it is. Okay, now let's calculate AC. That's root of 2 minus -3, so 2 minus -3 square plus 6 minus -3 and squared. As you see, this is really the same because this expression we can notice here and that expression is over there. So the overall value, you may want to check it on your own, it is still the same as before, root of 106. So yes, our original observation that these two sides are equal confirms. Okay, let's find side BC. That equals square root of, and we go 2 minus 6 square it, plus 6 minus 2, and square it. Okay, so what do we have here? 2 minus 6 is like negative 4, but when we square it, it's the same as 4 squared, which is 16. Plus 6 minus 2 is 4. When squared, it's another 16. So altogether we have root of 32. And this one we can simplify. We can split 32 into 16 times 2. So root 16 is 4 and root 2 stays. Here we go. However, our question calls for perimeter, so we need to add all those distances, which is root of 106 taken twice, so it's like 2 root 106 plus 4 root 2. And that's all what we can do here. So this is our final answer. One more example. This time we want to develop a formula for the diagonal D of a box. So here we have a box. Diagonal connects the most opposite vertices. So that's our diagonal D. And the box has given length L, width W, and height H. In terms of L, W, and H, we need to find the distance D. Okay, how can we do it? I wish you will stop this video and see if you can come up with some solution by yourself first. If you have any trouble, come back to the video and watch. Well, this diagonal D could be found by creating a triangle like this. We'll connect these two opposite vertices of the base, and this way we'll create a right angle triangle with diagonal D as hypotenuse, H as one leg, and this diagonal in the base, let's call it, for example, X, and right angle is between X and H. Why? Well, because this edge is perpendicular to the base. So no matter what line we draw in the base, the angle between this line and H will always be perpendicular. Okay, so we know that this triangle is a right angle triangle. We can redraw it on the side to see it better. This is our H, that's X, and this is diagonal D. Okay, therefore, from Pythagorean equation, we know that D by itself is the same as square root of X squared plus H squared, isn't it? So this is already a good formula. However, our formula is supposed to refer only to H, L, and W, but we have an extra variable X. So we need to convert this X in terms of L, W, or H. How can we connect the length X, for example, with L and W? Well, notice that W is not only here, but also there. That's the same distance. So this is our W, this is our L, and there is a right angle here. So let's look at this triangle. We may redraw it here. It will be in purple. This will be our W, L, right angle, and the hypotenuse is called X. So now we can connect those letters by Pythagorean equation. X squared equals W squared plus L squared. And the final step would be to replace this X squared in the first formula by the expression in terms of L and W. Okay, therefore we end up with D equals square root of W squared plus L squared, that's our X squared, right? And then plus H squared, the remaining H squared. Here we go. That's the formula for the diagonal of a box. Let's look back. What did we use? We used Pythagorean theorem twice. We used this purple triangle, this one in the bottom, to connect X with W and L. And we used the green triangle, this one, to connect D with X and H. Okay, let's use this formula to find the diagonal of a cube with side 5 centimeters. Since cube has all edges of the same length, the length, width, and height are all 5 centimeters long. So the formula becomes even easier. The diagonal is square root of 5 squared, 5 squared, and 5 squared. So it's really 3 times 5 squared. Here we go. We could pull the 5 out, And our answer is 5 root 3 centimeters. Exact length. Generally, the diagonal of a cube with side S has a formula S root 3. Try to convince yourself that that's the case. Remember, diagonal of a box is any line that connects opposite vertices, for example, this one. So if the side of a cube is S, the diagonal is S root 3.